Hi, I'm going to talk about data extraction for meta-analyses and then step 2, identifying study arms and comparison groups. In the previous video, I showed you how to identify outcomes in different types of study, but here we're going to focus on identifying your study arms or comparison groups. And so when you're extracting data, you want to get information on design characteristics, you want to identify the study arms, intervention, exposure characteristics, sometimes called arms details, your outcomes of interest, and your actual results, that is the measures of the outcome variable. In this video, we're going to focus on identifying the arms or comparison groups in a study. Now, first you have to figure out how study arms or comparison groups are defined. Arms are often defined or generally defined by the values of levels of the main independent variable, your treatment or level of exposure. Now, don't confuse a study arm or comparison group with a statistical model. And by that what I mean, authors will sometimes, especially in observational studies, create separate statistical models for different subgroups or subpopulations. And sometimes these are based on, say, age. So let's say that we're interested in the relationship between the number of fruit juice servings that people drink and their BMI. So here we have a weighing article, and what we're interested in, what we're looking for, is how the authors report that. Well, what we do, we read down blah 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 blah, and we have breakdown of fruit juice intake, but that doesn't tell us the relationship, so we're not interested in all that. Then they do this for adults, but when we get down to the actual relationships, what we find is that Wang and colleagues create separate models for 4 to 18-year-olds and another model for 19 or older. So what we need to really focus on is the authors break models up by age, but that's not what we're interested in. What we're interested in, our groups, are going to be defined by the levels of the independent variable, which in this case is fruit juice intake. And what we see, in this case orange juice, there are actually 1, 2, 3, 4 groups that they've done. Don't be confused by what our groups are for our interests, that is to say the levels of intake, so 4 groups, versus how they modeled it in creating separate models for kids versus adults. So if you're looking at this is the kind of the red herring, you may look at this and think, oh, okay, there are really 2 groups, kids versus adults. No, that's just how the authors model it. They're really, for our purposes, 4 groups. Non-consumers, first tertile, second tertile, third tertile. And sometimes they're based on things like sex. So here we have the Berkey article that we looked at earlier, where they're examining the relationship between amount of fruit juice intake, number of intake servings, and BMI. But what we notice is that because they measure this continuously, the number of servings, there's only one group. Our independent variable is a continuous variable. There's only one group. But what we notice is Berkey presents the outcomes, they model separately, not based on age or based on level of intake, but based on sex, boys versus girls. But don't be led astray. In this case, we've only got one group. That is to say, the continuous measure of our independent variable. The authors happen to model differently for sex, but that's not our group or our study arms. And basically, authors can create models or subgroup analyses based on darn near any kind of characteristic you want. But for the purposes of data extraction for a systematic review and meta-analysis, the study arms or the comparison groups are based on the independent variable of interest in your question. It doesn't matter what the authors did. What you want to define your groups on is the independent variable that you're interested in. So let's say that we're interested in how fruit juice consumption is related to BMI in children. Now, we don't want to be taken in by red herrings. So here's a Mackey's article that's looking at beverage consumption and anthropometric outcomes in children. Now, let me show you what they do. For their purposes, these authors are really interested in the differences in anthropometric outcomes really based on water consumption. So if you're just reading down through here and you're taking what the authors define as their groups, what you're looking at, you might think, oh, it's water consumption versus not. But we're not interested in water consumption. What we're interested in is the level of fruit juice consumption. And so what we have to do is we have to kind of ignore how the author has grouped it for a bit, and we look down through here until we find what we're looking for, and that is the relationship, the difference based on, here we go, fruit juice outcomes. Okay? So don't be taken in by what the authors have split it out as, the groups. What we're really interested in is the independent variable groups or groupings that we are interested in. So we wouldn't use, say, define two groups as water consumption versus not. What we would do is juice consumption versus not, which is how these authors finally break it down, but not until Table 6. So the point is, authors can create models on any old kind of subgroup or population. I mean, they're the authors, right? They can decide what they want to do. But these subgroups or population-specific models are not study arms or comparison groups for your purpose. Arms or comparison groups are defined by the levels of the independent variables that you are interested in. In clinical trials, this is really pretty simple. These are the treatment groups or study arms. In case control studies, it's also pretty straightforward. Your cases and your controls. I mean, duh, right? But in most observational studies, it can be pretty mushy. Different studies may be looking at the same exposure, that is to say the same independent variable, but they can measure it in different ways so that for the same outcome, the study arms or comparison groups can be defined very differently. If the independent variable is measured as a continuous variable, there may only be one arm or comparison group. And if we look back at the Berkey article, this is exactly what we were getting at earlier in this video. There's only one group because Berkey measures intake on a continuous scale, number of servings per day. And so even though he makes different models, boys versus girls, don't be taken in. There's only one group here, and that is, the intake. Boys and girls ends up being separate outcomes, okay? One group, beverage intake measured continuously, and two different outcomes for boys and outcomes for girls. Now, if the independent variable is measured as a categorical variable, say a yes-no variable, intake versus not, exposure versus not, right? Then there are two arms or groups. So here's the Mackey's article that we looked at earlier. And we saw that Mackey and colleagues are reporting results on fruit juice intake here. And they're doing it, looking at the relationship between fruit juice intake and the probability or the odds ratio. And so here's the Mackey article that we looked at earlier. And here we see is they're looking at the relationship between fruit juice intake and the likelihood of being overweight or obese. But we need to notice something important, and that is, how do they actually break fruit juice up? Is it measured continuously? Well, if we jump back to our methods section, or the methods section, what we find is that children are classified as having consumed the beverage if they reported 24-hour drinking any of these. So basically, it's they drank it or they didn't. So in our independent variable, there are two groups. There's consumed juice, didn't consume juice. So only two groups. Now, if the independent variable is measured a categorical variable, but they've broken it up into, say, tertiles or quartiles, whatever, then there are more than two arms or groups. For the Wang article that we looked at earlier, what we've got is they break the juice consumption up into 3 tertiles. So lowest, medium, high, tertile 1, 2, 3. And then they also have another group for non-consumers. So if we are interested in defining our groups, which we are, based on the independent variable, in this case we have 4 groups: non-consumers, consumers at tertile 1, tertile 2, tertile 3. Now, once you've located your outcomes of interest and identified the arm or comparison groups, then you need to identify how the results, that is to say the particular measures of the outcome, are reported. And this is important because how the results are reported is going to determine how you capture the results. And a really helpful tool is to use the Open Meta-Analyst program, and it's a free meta-analysis program created by the fine folks at Brown University Center for Evidence-Based Medicine. And there's the URL to get this. And in the next video, I'm going to show you how to use Open Meta-Analyst to help you identify or figure out what results you really need to capture when you're doing the data extraction. And that's the next video in the series.